Hello dear students. Today I am going to discuss the chapter 13 sound. Sound plays an important role in everyday life because the sound is a medium or sound is a form of energy which helps for the communication and the transfer of ideas, and there are many things in everyday life which is due to the production of sound. What is a sound? Sound is a vibration that travels in a pattern through a transmission medium, such as gas, liquid, or solid. It is a form of energy, or it can be heard when they reach the ear. So these are the basic things we already know regarding the sound. Sound is a vibration that travel in a pattern. That pattern we will call it as a waves, and it is transferred or it transmitted through a medium. That medium can be gas, liquid, or solid. And this vibration or disturbance produced by an object, that is an energy, because a particular form of energy is required for the production of sound, and it can be heard when they reach ear because it is detected by ear. So there are three phases or three aspects of sound we need to remember. That is, first one is how the sound is produced. Then that produced sound, how is it propagated through a medium? That means how is it transmitted? And the third one is how it is detecting or how it is sensing by a device or by the ear. So first let's start with the production of sound. Sound is produced by simply the vibration of an object. When an object vibrates, sound energy will be released or produced. And in humans, the sound is produced by the voice box or the larynx. It is at the upper end of the windpipe. Two vocal cords are stretched across the voice box in such a way that it leaves a narrow slit between them for the passage of the air. You can see here these two are the vocal cords. These two vocal cords are stretched across the voice box. This is the voice box, and this is the place where the voice box in our body. You can touch your throat portion, and where that bulging portion you can feel, that is the voice box. So here there is a narrow slit, there is a narrow gap between these two vocal cords. And when the lungs force air through the slit, the vocal cords vibrate. From the bottom part, when the lungs pushes the air, these vocal cords get a vibrate and produce sound. So this is the mechanism of production of sound in human beings. Then, what is that vibration? Let's understand what is vibration. You have already learned what is vibration. To and fro or back and forth motion of an object is called a vibration or an oscillation. There are two terms we will use generally. For example, look at here. You can see here, this is a simple pendulum, and this simple pendulum is oscillating. That means going left side and then come to the original position, then going to the right side. So this is repeating. That means going back and forth. So this motion is called an oscillation, clear, or vibration. Then all the musical instruments produce sound, certain type of sound depend on the instrument. So let's see what are the parts producing the sound by the musical instruments. In case of veena, it is stretched string. In case of tabla, it is stretched membrane. Guitar, stretched string. Flute, it is air column. Violin, it is the vibrating part producing sound is stretched string. So these are the some examples. You may get more examples by observing different types of musical instruments. Then how the sound is propagated. Here, sound needs a medium to travel, and it cannot travel through vacuum. We will discuss why is it need a medium to travel. Then what is that medium? The matter or the substance through which a sound is transmitted is called a medium. And it can be solid, liquid, or gas. Never think sound is propagated only through the air. It can be propagated through solids, liquids, such as through the wooden plank also it can be transmitted. There are many activities given in your textbook to prove this. So you can just refer those activities. Here I am just focusing only those important points. Sound moves through a medium from the point of generation to the listener. That is the first statement I said that sound needs a medium. Without medium, sound cannot propagate. So why is it need a medium? So for that, let's understand how this propagated. Then only we will get the answer why the sound cannot travel through vacuum. Here you can see a bell is the, and here a representation of eye, ear is the, okay. And as we know that, suppose this bell is vibrating in the air, and we know that air is a mixture of gases, and there are a lot of small particles present in the air. So when this bell vibrates, the molecule just near to, or the particles just near to the bell start to vibrate due to this vibration. Okay. And when this vibrating particle hits on the second layer, they also start to vibrate. And similarly, they transfer the vibration to the next layer. Similarly, the third layer of particles transfer their vibration to the fourth layer. Then finally, that vibration will reach to the ear. So here you can see that to propagate this vibration, the presence of particles is needed. The presence of particles is needed means a material is required. That is why we said that to propagate sound, presence of medium is necessary. If there is no medium, consider is it a vacuum, then there is no particle to vibrate or to transfer the vibration. Then the sound cannot travel through it vacuum. And moreover, the particle is not displaced from the production part to the listener. Only the vibration is transmitted. Particle, after the vibration of the particle, again it comes to the original position. Okay, so let's see here. When an object vibrates, it sets the particles of medium around it vibrating. The particles do not travel all the way from the vibrating object to the ear. A particle of the medium in contact with the vibrating object is first displaced from its equilibrium position or mean position or its original position where it was. It then exerts a force on the adjacent particle, that means second layer. As a result of which the adjacent particle gets displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process continues in the medium till the sound reaches our ear. Okay, so just to understand, the presence of particle is necessary for the propagation. Then how the sound is detected? The eardrum senses the vibration of sound. Okay, that ear is the organ which senses the sound in our body. Here you can see this is the eardrum, and this eardrum is like a stretched rubber sheet. Okay, it is like a stretched rubber sheet, that means stretched membrane, and sound vibration makes the eardrum vibrates. So when this sound vibration reaches here through the outer ear, this is the outer ear and this portion is inner ear. So when the sound vibration reaches here and through this canal, ear canal, it reaches on the eardrum, and this vibration makes the eardrum vibrate, and it sends this vibration of eardrum to the inner ear. From the signal goes to the brain. That means there are a lot of nerve cells present, auditory nerve cells present to transfer this vibration to the brain. That means this vibration will be converted into the form of electrical signals with the help of nerve cells, and through these nerve cells, these signals will go to the brain, and this is how we hear. So eardrum is the very important part of the ear which helps for the hearing process. Then what are the properties of sound or sound wave? Because as we already discussed the production, propagation and sensation, now we need to know something about sound, the characteristics of sound waves. First one is amplitude. What is amplitude? The maximum extent of the vibration of vibrating body from its mean position is known as its amplitude. Here we are not taking the sound here because to examine, to study the sound wave properties with the help of sound wave graph is very difficult. So we are just considering here a simple pendulum, because simple pendulum also follows a oscillatory motion. So let's consider a simple pendulum to study the characteristics of sound wave. So here this is the mean position or it is the rest position, and this is the extreme position where the simple pendulum can be displaced to the bird's maximum distance. So this distance from the mean position to the extreme position is called amplitude. The maximum extent of the vibration of vibrating body from its mean position is known as its amplitude. So this distance will be the amplitude. The second one is frequency. The number of vibrations or oscillations per second is called frequency. In 1 second, how many oscillations are produced or vibrations are produced by an object? That number is called frequency. Its SI unit is hertz. And the frequency of vibration can be calculated by the following formula. How? Frequency is equal to number of oscillations divided by time. Okay, small letter n represent number of oscillation and t represent time taken. So this formula is very important to calculate the frequency of vibrating object or oscillating object. The third characteristic is the time period. As we very simple quantity, that is the time taken by the vibrating particle to complete one oscillation is called time period. So we already know that the time period is the, for whatever it is, time period will be the time taken by the completing one particular thing. For example, in case of our school studies, we will call it as one period is for one subject. That means the time taken to complete one subject, 40 minutes, 45 minutes. Similarly, here the time period is the time taken by the vibrating particle to complete one oscillation is called a time period. And this can be calculated by the time taken by the number of oscillations. And by observing these two formula, F is equal to n by t and t is equal to capital T, that is the time period, is equal to small letter t divided by n. So by comparing these two formula, you can see that the RHS of these two equations are reciprocals of each other. Here n by t is the, here t by n is the. So we can obtain one more relation, that is t equal to 1 by f or f is equal to 1 by t, because they are reciprocals of each other. Okay. Next property, that is loudness. The sensation produced in the ear which enable us to distinguish between loud sound and faint sound or soft sound. That property is called loudness. How much intense that producer sound is, that is what we call it as loudness. And it depends on the amplitude of the sound. And it is proportional to the square of amplitude. That means if the amplitude is increased by 2 times, the loudness will be increased by 4 times, 2 square. If amplitude is increased by 3 times, then it will be increased by 9 times. 3 square is 9. So that is the relation between loudness and amplitude. When the amplitude of sound is large, we can call it as loud sound. Its unit is decibel. And there one chart is given in your textbook regarding the noise level of the sound based on the loudness. Okay, so just refer that table. So these are the basic things you need to remember in case of loudness. Fifth quantity, that is pitch. The characteristics of sound which distinguish between shrill sound and a soft sound. It depends on the frequency of the sound. For example, the sound produced by a whistle or some musical instruments are high pitch, while in case of sound produced by a drum, beating drum will be low pitch sound. That means high bass. Okay, and moreover, the sound produced by the females are high pitch, while the sound produced by males are low pitch compared to the sound produced by the females. So pitch is the characteristics of sound which distinguish between a shrill sound and a soft sound. Here the soft sound means it is sometimes we used to get the feelings of something penetrating to the ear. So like that feeling we will call it as a shrill sound. So it is because of the high pitch, and it depends on the frequency, not the amplitude. So these are the 2 points you need to remember. Loudness depends on the amplitude, pitch depends on the frequency of sound. If the frequency of vibration is higher, then we will call it as shrill and has a higher pitch. And the last property we are going to discuss, that is speed of sound. We are not going to discuss in deep. Just what is the speed of sound in atmosphere is approximately 340 meter per second. It will vary with the variation in the temperature and the pressure. And it varies in different media also. The speed of sound is greater in solids than in liquids than in gases. Why is it speed of sound is greater in solid? Because the distance between the particles in solid is less or small compared to the distance between the particles in liquids and compared to the distance between the particles in gases, because you already learned the properties of solid, liquid and gases. Okay, so that is the reason why the speed of sound is greater in solids. Okay, so these are the 6 important properties of the sound waves. Next, let's examine this loudness and pitch in terms of the graph. Here you can see that one soft sound is there, one loud sound is there. And here, faint sound is due to small amplitude, and here loud sound is due to higher amplitude. Okay, this is just a graph represent the sound wave. And here you can see amplitude is same. Comparing this distance, you can see amplitude is same, but the number of oscillation is different. So here less number of oscillation, that means less frequency or low pitch. It is a waveform of a bass guitar. While here the number of oscillation is greater compared to the first case. That's why we will call it as a high frequency wave or high pitch sound. This is the graph of the sound wave produced by a whistle. Okay, so this is the difference. Frequency determines the pitch and amplitude determines the loudness. Clear? And now we are going to classify the sounds. There are two classifications. One is classification on the basis of frequency and classification on the basis of quality. So first let's discuss the classification based on the basis of frequency. There are two classification mainly we have done on the basis of frequency. One is audible sound and the second one is inaudible sound. Sound having frequency is between 20 Hz to 20,000 Hz are heard by human ear. Because of that, we will call it as a audible sound. And what are inaudible sound? The sounds having frequency above 20,000 Hz and below 20 Hz. From 20 to 20,000, human ear can be heard, while below 20 and above 20,000 Hz cannot be heard by normal human being. Because of that, we will call it as an inaudible sound. And again, these inaudible sounds are classified into two: ultrasound and infrasound. Infrasound means sound having frequencies less than 20 Hz. That is what we call as infrasound. Ultrasound means sound having frequencies greater than 20,000 Hz. Even though normal human ear cannot detect this inaudible sound or infrasound and ultrasound, there are some animals those who can hear these sounds. For example, dog. Some policemen use a particular type of whistles which produce ultrasound to control the dogs, because that sound produced by the whistle cannot be heard by the human, but that can be heard by the dogs. So according to that, they can control the dogs. Okay, and not only dogs, there are many animals in this world. They can detect ultrasound and infrasound. So the second classification on the basis of quality. There are two sound waves we can say on the basis of quality. One is sound, music and noise. From the word itself we can understand the sound which produces pleasing effect on the ear is called music, and the sound which produces an unpleasant effect on the ear is called noise. And the last topic we are going to discuss, that is noise pollution. The presence of excessive or unwanted sound in the environment is called noise pollution, like water pollution, air pollution. Clear? Presence of excessive or unwanted sound in the environment is called noise pollution. So let's discuss the sources, harms and the measures to limit the noise pollution. First, what are the sources? Sounds of vehicles, explosion including bursting of crackers, machine, loudspeaker. Okay, these all are source. And television, transistor, radio at high volumes, some kitchen appliances, desert coolers, air conditioner, etc. These are the sources in the home, and these are the sources outside the home, that means industrial sources. So here there are many sources. These are the sources just given in your textbook. There are so many sources we can obtain if you are taking a list. And remember that if we are not supposed to use these types of loudspeakers or sound systems beyond the particular limit allowed by the government and during the celebrations or festivals. So this is very important. And remember one more thing, that is we are not supposed to use these types of sound systems for any kind of celebration after the particular time allowed. And the harms of the noise pollution, many are there, just given some are in the textbooks that I just noticed here. It may cause health related problems like lack of sleep, hypertension, that means high blood pressure, anxiety. These are the some psychological and some physiological health related problems caused by the noise pollution. And a person is exposed to loud sound continuously may get a temporary or even permanent impairment of hearing. That means the hearing capacity will be uh, eliminated from the ear. We should not use the earphones in too loud sound for continuously 2 3 hours or 4 hours. So that is also very important to remember in everyday life. Okay. And the last one is that how can we reduce this noise pollution? A silencing device must be installed in aircraft engine transport in all the vehicles, and there's some home appliances also. Because as you know that the silencer have many purpose to pull out the air, pull out the smokes which are produced by the engine, as well as to silence the sound produced by the engine. So that devices we should must be installed in the vehicles. And moreover, the silencing device provider or the silencer provided by the manufacturer is the good silencer, and we are not supposed to change it by any other modern one to get a loud sound. There are some people they are using the alternate silencing silencer, which replaced by the silencer provided by the manufacturer to get a loud sound. Okay, especially in the bikes. So we should not do such types of activities. And all noisy operation must be conducted away from any residential area, whether the mining or any other industrial activities which produce noise. It should not be conducted in the residential area. It should always conduct away from the residential area. And use of automobile horns should be minimized because especially in the forest areas, it disturbs the animals. Okay, and TV and music system should be run at a low volume, because even if we are at our homes, we should play these, we should run these all devices with a low volume which is enough to hear by our ear. So that also very important to remember. And trees must be planted along the roads and road buildings to cut down the sounds reaching the residents. And planting the trees have a lot of advantages there, but one of the advantages is that it will reduce the noise pollution because it will cut down the sound coming from the roadside, and it will be scattered so that it will not come to the resident area and it will not affect our freely life. Okay, so these are the topics we have discussed. Remember to read the textbook thoroughly, because here I have just discussed only the important points which are given in your textbook. What is a sound? Production of sound, propagation, detection, classification, and properties. So these all are just important topics. Also, you have to read the textbook. Okay. So next video I will come with another chapter. Thank you all.